Good morning, dear students. Welcome back to physics class. For today's class, I would like to present the topic energy and its different forms. You can remember now in beginning of this chapter, work and energy, I had mentioned the term energy when I was talking over the concept work. You know that all life processes need energy. We need energy to perform different activities. Energy required to carry out various life mechanisms in living beings is obtained from food that they eat. The word energy is very often used in our daily life, but in science it has a definite and precise meaning. What is energy? Energy means capability in doing work. Which is biggest natural source of energy to living beings? Answer is the sun. Life is impossible without the availability of the solar energy. What is solar energy? Energy which is derived from the sun is the solar energy. How can justify the statement that life is impossible without the availability of the solar energy? You know that all animals, included with human, depend on plants for their food directly or indirectly. But plants prepare the food and store it in the form of chemical energy by means of photosynthesis process. What is photosynthesis process? It is the biological process by which plants prepare the food by taking up carbon dioxide and water in presence of sunlight and synthesize food by liberating oxygen. But this process cannot be carried out by lack of solar energy. I think now you understood the importance of solar energy. It is also understandable that many of our energy sources are derived from the sun. Energy required for our other various purposes, examples domestic, industrial, agricultural, commercial, and scientific work, is also obtained from the nuclei of atoms, the interior of the earth, and the tides. Hydropower or hydroenergy is not neglected subject in this regards, which is the energy derived from the flow of water. Can you think of other sources of energy other than solar energy? They are wind energy, tidal energy, geothermal energy, atomic energy or nuclear energy, etc. Let us consider the following examples. First one is when a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. Second one is a person may be get severe injury or he may be shot dead when a fired bullet hits him. Third one is when a raised hammer falls on a nail placed on a piece of wood, it drives the nail into the wood. Here, an object when raised to certain height gets the capability to do the work. Fourth one is wind a toy car or key up the toy car and place it on the floor. It starts moving on the floor. Here, the toy car uses the stored energy due to its winding up to move it forward. Is cut into number of logs in dessert shapes by a fast moving blade in sawmill. Here, the fast moving blade is having capability to do the work against the wood in order to cut the wood into number of pieces. And sixth one is when you press a air-filled balloon, you notice that a change in its shapes. As long as you press it gently, it can come back to its original shape when you release the force. That is, the balloon uses the stored energy due to its earlier compression to come back to its original shape when your applied force is released. However, you press the balloon hard, it can even explode, producing a blasting sound. In all these examples that I told, the objects acquire through different means the capability or capacity of doing work. An object, when it is having a capability or capacity to do work, is said to possess energy. The object which is doing work loses energy, and the object on which the work is done gains energy. Now, one question is there for you. How does an object with energy do work? Answer is, an object that possesses energy can exert a force on another object. When this happens, energy is transferred from the former to the latter. The second object may move as it receives energy and therefore do some work. Thus, the first object had a capacity to do the work. This implies that any object that possesses energy can do work. Now, I am going to discuss on units of energy. What are the units of energy? The unit of energy is the same as that of work because energy possessed by an object is measured in terms of its capacity of doing work. You know that SI unit of work is joule. So, SI unit of energy is also joule, which is represented by capital letter J. How can we define 1 joule of energy? 1 joule of energy is the energy required to do 1 joule of work. Its CGS unit is erg. 1 joule is equal to 10 the power of 7 ergs. This is the conversion of 1 joule of energy into corresponding value in CGS unit, that is ergs. Larger unit of energy in common use is kilojoule. 1 kilojoule is equal to 1000 joules or 10 the power of 3 joules. Let us go through this subject, classification of energy. Energy can be broadly classified into two types. They are kinetic energy and potential energy. Both kinetic energy and potential energy are the parts of mechanical energy. Some examples of energy are thermal energy, mechanical energy, electrical energy, magnetic energy, sound energy, light energy, chemical energy, elastic energy, nuclear energy, gravitational energy, etc. Some forms of energy are derived from the state motion. So, they are the examples of kinetic energy, which are thermal energy, electrical energy, magnetic energy, etc. But some forms of energy are stored in objects which are to be used later. They are in the form of potential energy. Examples are chemical energy, elastic energy, nuclear energy, gravitational energy, etc. This slide gives the pictures of various sources of energy and you can understand their forms. This slide also gives the examples of various forms of energy. You have to remember that various forms of energy are mechanical energy, heat energy, chemical energy, nuclear energy, magnetic energy, electrical energy, sound energy, light energy, etc. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.